Hello everybody, we are going to dive deep into Numpy module today. If you have watched my previous tutorial, you have initial idea on what Numpy module is and how to install it. In this tutorial, we are going to take a detailed look at Numpy's array object, which is the main feature of this module. So let's begin by importing Numpy as np. Now, as you all know, you can create multi-dimensional array in numpy using np.array. Now this is how you create, let's say, one-dimensional array, and you can access it just like your list. But to create two-dimensional array, you can do again the syntax looks pretty similar to how you would do it with a normal Python list. So you create your two dimensions and you initialize it with these list of elements. So this is my two-dimensional array. Now there is this property called ndim that you can use to print the dimensions. Okay, so if you have, let's say, this array, and if you print ndim, it will be 1. But now I have this two-dimensional array for which the dimension will be 2. Okay, there is item size property which will print the byte size of each of these elements. Now these are integer elements, so that's why the item size is 4 bytes. As you know that integers occupy 4 bytes. If you have float number, so let's initialize this array with float as a data type. Now before I do that, let me print the current data type of this array. So here it is saying it is integer 32. Now if I want to initialize the same array with a different data type, then I need to use dtype argument. So here you can say dtype is equal to np dot, here you can say float 64. So float 64 is one of the types. Now 64 means it occupies 8 bytes. So now when you print the item size, instead of 4, it's gonna be 8, because now each of these elements, they are float numbers and they occupy 8 bytes. So if you print a here, you can see 8 1 point something. So this is now float. Okay, so let me just clear this. All right, another important property that an array has is let me just create. Okay, so it is size. So size is basically the size of your array, total number of elements. So here you can see 1 2 3 4 5 6. So it has like total 6 elements. Then you have shape. So shape represents the information on dimension, so sort of like width and height. So here it has 3 rows, so 1 2 3, so 3 rows, and 2 columns, so 1 and 2. All right, now we already covered the dtype argument. So here I covered the dtype argument. Let me just copy it from here. So you can use dtype to initialize your array with a specific data type. Okay, so so now instead of float 64, you can also specify your type to be the complex number. So if you say complex, what it's gonna do is it's gonna create an array with complex numbers. Now sometimes you want to initialize your array with some placeholder numbers. Let's say you want to initialize your array with all zeros. If you want to do that, you will use np.zeros function and just mention your shape here. Shape means the information on your dimension. So this is creating an array of 3 by 4, 3 rows, 4 columns, 1 2 3 4, all initialized with zeros. You can do same thing but with ones. So instead of zeros, you will say ones, and it will initialize all the elements with one number. Now sometimes you want to use a function similar to range. So you know that in Python there is this range function that we use for list, right? So what this function does is it's gonna create a list of numbers from 0 to 4. So that's what it did. Now numpy also has similar function. It is called a range. So if you do np here, if you do np dot a range, array range basically 1 to 5, then this is gonna create a array of 1 to 4 numbers. So 5 is not included by default. That's how even range function behaves. So this is very similar to Python's native range function. Okay. Now sometimes you want to do the same thing. So let's say initialize array which from 1 to 4, but then you want to have like steps of 2 numbers. So this means that you start at 1, then you take a step of 2. So 1 plus 2 is 3. 3 plus 2 is 5, but then this is your end. So this is your start, this is your end, and these are like number of steps. So once you reach 5, you will stop. So that's why it is 1 and 3 here. You can also use a linspace function. So let me demo that. np.linspace to, now here you will specify your start number and end number first. Okay, so you will say, okay, my start number is, let's say 1, and my stop number is say 5, and in between these two numbers I want to generate, let's say 10 numbers. Okay, so what this will do is it will generate 10 numbers between 1 and 5 which are linearly spaced. So you can see that you got this nice range of 1 and 5, and then these numbers are linearly spaced. Now if you do the same thing with, let's say 5, then they are spaced by number 1. Okay, you can do whatever, you can do even 20. This is pretty useful if you want to create like this linear sequence of numbers. You can also reshape your arrays with reshape functions. So for example, if you have this array, and then the shape of this array is 3 by 2, it has 3 rows and 2 columns. Now let's say you want to reshape this to be 2 by 3, so you can say reshape 2 by 3. Basically now you want 2 rows and 3 columns, and it would work. So you can reshape it to any dimensions that you like, and the dimension should be compatible with your initial dimension. So you can even do a dot reshape to be let's say you want, let's say 6 rows and 1 column. So you see 6 rows, 1 column. You can also use a ravel function to flatten your array. So this will just flatten it, make it 1 dimension. So you have n dimension array, when you call a.ravel, it will flatten it, make it 1 dimension. All right. Now when I print a after flattening it, I see that it's still an original array because a.ravel will not touch the original array. It will return a new array. So you can capture the output into a new variable and have access to flattened structure. So that applies to all of these functions. Just remember that it's not gonna alter your original array. So that's something you have to keep it in mind. Now let's look at some of the mathematical functions that numpy array covers. So you have many functions. So let's say I have this array. Okay, if you do a.min, it's gonna print your minimum element, which is 1. A.max will print your maximum element, which is 6. Okay, now you can also do a.sum, and it's gonna sum all the numbers together. Now there is a concept of axis in numpy array. Axis means your dimensions. So my axis 0 will be these columns, okay, and my axis 1 will be these rows right here. So when I do a dot sum and when I say x is equal to 0, it's gonna look at each of these columns. So it added these numbers together, 5, 3, 8 and 1, 9. So it printed 9. 6, 4, 10 and 2 is 12. So it's added these together and printed 12. If you want to sum all the elements in rows together, then you use axis 1. So here 2 and 1 is 3, 3 and 4 is 7, 5 and 6 is 11. So that's what it did. So that's what the axis means here. You can also do a square root. So if you do sqrt, a dot sqrt, let's see. So if you do, so square root is not a function of individual array element, it's a generic function. So you have to do np.sqrt. so np is your numpy module. So it's gonna compute the square root of each of these numbers. So for example, 4 square root is 2, then 2 square root you don't remember, but if you open your calculator and find the square root, it's gonna be this. Okay, you can also do standard deviation. So np dot standard deviation. So standard deviation of all these numbers is here. Again, no one is gonna remember this, but if you do your math, then you will find that it will be this number. Okay, we are going to now look at some basic mathematical operations, and for this I'm going to have these two arrays. I just copy pasted it from my notepad, but it didn't work. Anyways, I will just create it here. So I have two-dimensional array here. So 1, 2, 3, 4. Okay, and I have this second array. Okay, this is my first dimension. My second dimension is 5, 6, 7, 8. Okay. Oops, I forgot closing angle bracket. Okay, so I have these two array, A and B, two-dimensional array. Now NumPy supports very basic operations such as, let's say if you want to add them together, you can do it using plus operator. This is something you can't do with Python native list, so it's very convenient with NumPy arrays. So this added these together. 5 and 1 is 6, 6 and 2 is 8. It's basically adding the individual elements. You can do multiplication, you can do division, you can do all sorts of operation. You can also do a matrix product. So if you do a dot b, it's gonna do matrix products of these two individual matrices. All right, so that was all about NumPy array. It wasn't all about NumPy arrays. Actually, we still need to cover a few topics such as indexing, slicing, iterating, stacking these NumPy arrays together, but all those remaining things we are going to cover in our next tutorial. Until then, thank you for watching and good luck with your Python and NumPy learning. Thanks again. Bye.